one quite specific area of the physics specification that isn't always highlighted in lessons. So the 2 points in the specification are here. You might want to pause the video now and read these. So when we teach this, how would we teach it? Well, we would probably start with a general explanation of how we create electromagnetic waves, right, which is also another point on the specification. So we obviously know what atoms look like, and we know that there are electrons in shells. Now, if a photon comes along and is absorbed by an electron, that electron can be promoted to a higher energy level. If an electron is at a higher energy level and it drops down into a lower energy level, then it can emit a photon. And if the gap in energy is greater, so maybe we're going to an even higher energy level shell, then that change in energy is obviously greater, so there will be a greater energy photon released. So it might be that this is visible light and this is ultraviolet, as an example. Now, we can be a bit more general than this. So this is a point on the spec, but we can be a bit more general on this. We can say, in general, moving charges create electromagnetic waves. So this is true, and this is going on all the time around us. But actually, if you just move a charge, you will create an electromagnetic wave. So if you got your hand and you waved it back and forth fast enough, right, with a high enough frequency, you could create electromagnetic waves because you've got electrons in your hands and you would be moving them. Now, there is one exception. The exception here, which is important because, again, this is another point on the spec in the radiation topic, is that gamma rays come from unstable nuclei. And that is made very clear in the radiation topic. So why does this come up in the waves topic? Well, there is one quite specific point about radio waves. So here is an aerial, it's a television aerial, could be a radio aerial, and in this aerial there is going to be an alternating current, an AC current, so the current is going backwards and forwards many times each second. So because of that, we have electrons that are also doing this, moving back and forwards. So what does this end up creating? This creates a electromagnetic wave, and it creates a radio wave. So at this point, it's probably useful to link this to what we actually mean by the structure of an electromagnetic wave, which we should have looked at. So an electromagnetic wave, the wave is obviously moving in this direction, but what is it actually? It's the oscillation of two different fields at right angles to each other, where we have the electric field and we also have the magnetic field, which in this case I'm drawing up and down. So this is how we create radio waves. If they then come upon another antenna or aerial, so this is now the receiving aerial, then what's going to happen? We are also going to induce an AC current, and it's going to have the same frequency as the initial signal or the initial or just the radio wave in general. All right. So this is obviously then very important, all right, because what is the implication? We can transfer information using radio waves, all right, which is also something that they will test. So if there was an exam question that sort of said to describe this process, what three things would you write down? We'd probably write down the oscillating electrical current in the transmitter. So this one here is obviously a transmitter. Produce EM waves or radio waves. We would then say the radio waves are absorbed by the receiver, and we would also say that the frequency is always the same. Now, depending on the ability of your class and exactly where you are, you might want to link this to the electromagnetism unit, because you can talk about the fact that you've got a current. A current will obviously create a magnetic field. A magnetic field moving through a wire will induce a current. So all of these things are taught in the electromagnetism unit. But when you teach it in waves, it is limited just to this description here.